Okay, so the similar triangles proof for equal angular triangles. Okay, so if they give you in an exam these two triangles, okay, and they say you must prove that DE over GH is equal to DF over GK, which is equal to EF over HK. Okay, that's what you must prove. You must basically prove that the ratios between the bigger and the smaller one stays the same. Okay? How you do it is, well, normally they're just going to ask you two, not all three. Otherwise the proof is very long. You will see most of the time, they're just going to ask you, for instance, prove this over this is equal to that one over that one. Okay, but we can maybe look at the whole thing. It is a bit long. But like I say, most of the time you can expect them to ask you just to do two of the three sides. Okay? So the first thing you do is you say, you use a construction. Okay? You make a construction. That's very important. You get a mark for your construction. Okay? So you're going to say on DE, put in M, so that GH is just as long. Okay? So we're going to put it there, basically, M, and then on DF, put N. Okay? So that when you draw this line, MN, this triangle is supposed to be congruent with that one. Okay? So you're going to say, draw MN on DE and DF. Okay, so construction M on DE, so that DM is equal to GH. DM is equal to GH. And you put N on DF, so that DN is equal to GK. Okay, so that's your construction line. So now this one must be equal to this one, and that side must be equal to that side. So these two triangles, you want them to be congruent. And now you prove it. Now you can say, so in triangle GHK and triangle DMN, we can say, first of all, we can say that this angle D is equal to G. Okay. Angle D is equal to angle G. It's given. Because remember, in the start of the question, they're going to tell you that this angle is equal to this one, that angle is equal to that one, and that one is equal to that one. That's what they give you. Okay, so all they gave you is two triangles where the angles are equal. Okay, and you must basically use that to prove that the sides are proportional. So the theorem actually says, if two triangles are equiangular, their corresponding sides are in proportion. So the theorem says, if two triangles are equiangular, if they're equiangular, then the sides are in proportion. So it's something we know from grade 9 with similar triangles. We know from grade 9 already that if the triangles are similar, then the sides are in proportion. But now we're just proving it. Okay? And how we prove it is by using the fact that the angles are equal to prove that that means the sides are also going to be in proportion. Okay? So we're going to prove congruency. So we did this angle equal to this one because it's given. Then we can say DM is equal to GH. Okay? Secondly, we can say that DM is equal to GH because it's our own construction. We made a construction so that they can be equal. And then thirdly, we can say that DN is equal to GK. Okay, so our third reason is DN is equal to GK. Okay, it's also our construction. And therefore, we can say these two triangles are congruent. So we can say now GHK is congruent to DMN. And our reason? Side, angle, side. Side, angle, side. S, A. So that's the first part of the proof. Okay? That's the most important part. Because if you get this part right, the rest just kind of follows on that. So let's just recap this part. Okay? We want to prove that the sides are in proportion. We first draw line NN so that this side is equal to this side, that side is equal to that side, and then we prove that these two triangles are congruent. Okay, so that's the first part of the proof. Okay, so with the second part of the proof, if we know now that these two triangles are congruent, what does that mean? If they're congruent, it means that you can say that means this angle must be equal to this angle. Okay, obviously, because they're congruent. Okay, so we can say now, therefore, angle DMN, okay, is equal to H, because of the congruency. Okay, we just proved it, so we can say they're equal. Okay, but we already know that E is equal to H. We know that from the start. We know that E is equal to H. Okay, so if DMN is equal to H, we can say therefore DMN must be equal to E. Okay, DMN is equal to H, therefore DMN is equal to E. And that's important because if we now said, okay, this one is equal to this one because of congruency, but that means because these two are equal, okay, that's, we can say it, DMN is equal to E. Why? Because H is equal to E. H is equal to E. That was our own starting point, that H is equal to E. Okay? Then we can say, therefore, these two lines must be parallel. Therefore, MN is parallel to EF. Why can we say that? Because if the angles are equal, they're corresponding. So the angles are equal, we showed it, they're equal, which means they're corresponding angles, which means the lines must be parallel. So our reason is because of the corresponding angles. Okay, that's basically it. So that's how you show that the lines are parallel. And think about it, if the lines are parallel, then you can go back to the previous theorem that says when one line is parallel to another one, the sides are proportional. Okay, so then we can say, okay, so therefore because we showed that, it means that we can now basically prove this DE over DE, but we can first say DE over DM. We can say, because they are parallel, we can say therefore DE over DM must be equal to DF over DM. Okay, and therefore DE over GH must be equal to DF over GK. Why? Because DE or DM is equal to M is equal to GH. Okay, those two are equal, and DN is equal to GK. Okay, because that's what we got from the start. This one is equal to this one, that one is equal to that one. So if this one over this one is equal to this side over this side, then we can say this side over that side must be equal to this side over that side, because that one is equal to that one, and that one is equal to that one. Okay. Okay, so now the last part of the proof. Okay, so this is normally where the proof stops. Okay, that's what we did was normally the proof. But we proved that this over this is equal to this over this. That's what we proved. Okay? But what if they wanted to prove all three? Chances are very small. But if they ask you to prove all three, then you have to carry on and say similarly, which means you're not going to do the whole thing again. Because similarly means in the same way, I can do what? I can say, similarly I can say, instead of putting in this line, I can put in a line here, there, okay, that's parallel, a line there, not parallel, so that this one here, let's call it P somewhere. So that P from E to P will be equal to GH. Okay. Similarly, okay, we can, let's just say, draw or sketch P so that EP is equal to GH, and let's call it Q. There, Q, okay? And Q so that EQ is equal to HK. Okay, so we can do that and then say this one is equal to this one, that one is equal to that one, and then we forget about that first part we did. We basically just put in this and this. And then we can prove so that they're equal, and then we can show that EP over, or this last part, DE over, let's just put it in, DE over GH will then be equal to EF over HK. Okay, EF over HK. Okay, so you can say similarly I can put in this triangle, and then obviously I can prove, let's just say and prove DE over, so then we can prove that. And therefore, if we prove this, we can say that all of them, then DE over GH is equal to DF over GK, which is equal to EF over HK. So all the sides are in proportion, and therefore the two triangles are similar.